As we continue in our series of making measurements with standard electrical engineering tools, we have our multimeter in front of us. This time we want to make current measurements. Last time we saw how to make voltage measurements. This time we want to measure current. And so in order to measure current, we have to make sure that the meter, the multimeter, is placed in series with whatever element you're interested in knowing the current of. All right, so first of all, we have to set our instrument, and we'll turn the power on. We will select AC or DC. In this particular case, we'll be interested in DC measurements, as you will be in your first labs. Instead of a voltmeter, we will select an ammeter, which is a milliammeter. And we may not know what range to choose, so we may want to go to the highest range, which is 2,000 milliamps, maximum of 2 amps. That's what this is fused for. The instrument will read 1999, which is 1,999 milliamps, or 2,000 milliamps, or 2 amps. Right? So we've selected the range, we've selected the instrument. Now we have to select the terminals. We do not want the voltage terminal. The common terminal is fine. We'll put the red lead into the milliamp terminal, and we now have ourselves a DC milliamp instrument capable of measuring up to 2 amps. So now, how do we go about doing that? The red terminal is the terminal which the current flows into. The black terminal is the terminal which the current flows out of. And so if I were interested in measuring the current in this particular resistor, I would have to make sure that the current going through the ammeter was the same as the current going through that particular resistor. And if I simply put that terminals across, that would be incorrect, because that's the way you do a voltmeter. I don't want them in cross, I want them in series with. So what I have to do is I have to take the resistor, I have to break the circuit so that it's not connected anymore, and then I fill in the place that I just broke the circuit with the ammeter. Now the ammeter and the resistor are in series with each other. Whatever current flows through the resistor is the same current that flows through the ammeter, and the ammeter will give you the reading that you desire. All right, so ammeter measurements are always a little more difficult. You first have to remember that you break the circuit. So where the configuration here shows 2 resistors in series, I have to open the circuit up so that they're no longer connected to each other. That leaves, if you will, a hole in the middle of the circuit, and then I take the ammeter and I fill that hole. And I put the red lead on the top, on the end of one resistor. I put the black lead on the end of the other resistor. That completes the circuit. Whatever current that those 2 resistors were causing to flow will now flow. The ammeter will record that, and I have the reading in front of me as desired. If the reading comes out negative, it simply means that the polarity that I've chosen is the wrong way around. And if I want a positive reading, I would simply swap the 2 terminals. But if I'm interested in reading the current in this resistor from top to bottom, I must put the red terminal such that the current flows into the red terminal and out of the black terminal through that resistor. So now I'm measuring the current flowing from the top to the bottom. If I want to measure the current from the bottom to the top, again, polarity is important. I'll put my red lead on the resistor of interest. I'll put my black lead on the other resistor. Now I'm measuring into the red terminal, out of the black terminal. This is measuring the current from bottom to top through this particular resistor. So always remember, when you make current measurements, you have to open the circuit, you have to break the circuit. And the other thing that you always have to be aware of is the terminal that the leads are connected to. This milliamp terminal is a fused terminal. There's a 2 amp fuse sitting underneath there, and if you exceed the current, if you go more than 2 amps for whatever reason, you will blow that fuse and you will not get any readings. Here is the most common way in which people will cause a problem. These two resistors are connected together. I'm interested in measuring the resistance in the top element. Many people will simply configure their device as an ammeter, and then they will go across that resistor. By going across that resistor, you're putting a device with a very low resistance. An ammeter has a very low resistance in parallel with this resistor. All of the current is going to flow through the ammeter, not the resistor, and therefore you're going to get currents that are much higher than they should be in the ammeter, often leading to a blown fuse, and then the instrument no longer works for you. So remember, if you're going to measure the current in a resistor, you have to separate that resistor from the rest of the circuit and then use the ammeter to fill in the hole that you've just made. Alright? So that is how we use an ammeter. Folks, this is the second in a series of laboratory videos, and what you see in front of you is a pretty standard power supply. There's essentially two power supplies. We find that there is half on one side, half on the other side, and either of those two power supplies may operate as a voltage source or as a current source. And there are two controls on here. One is the voltage control, and if you turn the voltage control all the way up, turning it clockwise as far as it'll go, that allows the device to be controlled as a current source. And the second control will then control exactly how many amps will flow. If you turn the current knob clockwise as far as it'll go, that reverts the control to the voltage knob, and it becomes a voltage source. And so these devices are capable of putting out about 3 amps, maybe 2 amps. In this particular case, it's 2 amps here, and about 25 volts. So we can have up to a 25 volt source. We can have up to a 2 amp current source. So it can be one or the other. Most of the time we will use this in the voltage control mode. That will be the standard way in which you use these power supplies. So you have a power supply on this side which will be controllable. We have suggested that this could be a 5 volt supply, and you have a power supply on this side which is controllable. We have suggested that it is 10 volts. Alright, so that's the basic power supply. On-off switch occurs here, turns it on, turns it off, and we enable it using the power switch. Some of the other power supplies we have a specific enable switch, so that when the power is on, you can dial up whatever it is that you want the power supply to be doing, and then you finally press the enable button to enable the terminals to do what it is that you've just asked it to do. So if you have one of those power supplies, you'll be looking for an enable button down near the output terminals. In this particular case, we just use the on and off power as the controller of the output. In the output section, you will see that there are 3 terminals: a plus terminal, a minus terminal, and a ground terminal. Neither the plus terminal nor the minus terminal is actually grounded or connected to the earth or connected to the chassis, which is what the ground establishes. So these, the red plus and the black minus are independent of those, but it's the red plus and the black minus, that's where you get your output. So for example, we turn this thing on, we dial this totally clockwise in the current, and then we'll adjust the voltage until it goes all the way down to 5 volts, and we have created a 5 volt voltage source. The 5 volt voltage source, the red terminal, will be 5 volts higher in potential than the black terminal. And so we would connect our connections like this, so that the red terminal goes to the positive side and the black terminal goes to the negative side. So that's how you use these power supplies. You rarely need to connect either of the red terminal or the black terminal to ground. Some special circumstance will allow you to do that, or will force you to do that, but generally you don't have to do that. All you're looking for is the fact that the red terminal is 5 volts in this case, or 10 volts, or whatever voltage you dialed up, greater in potential than the black terminal. So basic power supply, almost all power supplies are dual power supplies, and we can use them in a dual mode. So for example, you want a integrated circuit to have plus and minus 5 volt supplies, then what you would then do is you would connect the minus of the first one to the plus of the second one. This becomes your common terminal. The red terminal is 5 volts higher than the black terminal, and on this side, the second power supply, the black terminal, would be 5 volts lower than the red terminal. So if this jumpered connection is a common point, you'll have plus 5, and on the other side you'll have minus 5. So the dual power supply can be used in unison to give you a plus-minus supply, or it can be used independently as 2 separate supplies. So in the first part of your term, you will be using your power supplies as independent power supplies. Once we introduce op-amps and other integrated circuits, you will need this as a dual power supply. So we'll leave it there for now, introduce you to the power supply. All right, see ya.